What if I told you that a giant mass of warm water sitting in the middle of the Pacific Ocean is about to reshape the weather of the entire planet? And scientists are already calling it Godzilla? Not because they're being dramatic, not because they want clicks, but because the data coming in right now is pointing towards something that hasn't been seen in over a century. We're talking about a super El Niño event, one that could potentially break every record set since modern climate science began tracking this phenomena. And the effects of what's coming won't just be felt in one region or one season. We're looking at years, specifically 2027, 2028, and possibly well beyond, of disrupted weather patterns, extreme temperatures, and serious consequences for food production and economies across the globe. So if you've ever wondered what El Niño actually is, why scientists are suddenly panicking about this one in particular, and what it could mean for the part of the world where you live, you're in exactly the right place. Stay with me, because what we're about to break down is not speculation. It is science, backed by the latest forecast from the European Center for Medium-Range Weather Forecasts, and it is happening right now. Let's start with the latest numbers, because they are genuinely alarming. According to recent projections, sea surface temperatures in the Central Pacific are rising at a rate that is significantly higher than anything we typically expect at this time of year. Some climate models are now projecting a temperature anomaly of approximately 4 degrees Celsius above average. To put that into perspective, most El Niño events that we consider strong involve anomalies of just 1 to 2 degrees. A 4-degree shift would place this event among the most powerful in recorded history, potentially surpassing the legendary El Niño events of 1997 and 2015, both of which caused widespread destruction across multiple continents. The probability of this event forming in the coming months is now estimated to be somewhere between 80 and 90%. That is not a maybe. That is almost a certainty. And that is exactly why climatologists are reaching for a name that matches the scale of what they're seeing. And the name they've landed on is Godzilla. But before we talk about what this means for the future, we need to understand what El Niño actually is. Because a lot of people have heard the term without ever really understanding the mechanics behind it. Why does a patch of warm water in the middle of the Pacific Ocean end up causing droughts in Australia, floods in South America, warm winters in Canada, and record-breaking global temperatures? The answer lies in a beautifully complex and deeply interconnected climate system known as ENSO, the El Niño Southern Oscillation. And to understand ENSO, you need to picture something surprisingly simple. Imagine the tropical Pacific Ocean as a giant bathtub. Under normal, neutral conditions, powerful winds blow steadily from east to west across the surface of this bathtub. These are the trade winds, and they play an absolutely critical role in regulating the temperature balance of the entire Pacific basin. They push enormous volumes of warm surface water westward, causing a buildup of heat near Australia, Indonesia, and Southeast Asia. Meanwhile, on the other side of the Pacific, near the coasts of Peru and Ecuador, that warm water being pushed away creates a vacuum of sorts. Cold, nutrient-rich water rises up from the deep ocean to fill the gap. This process is called upwelling, and it keeps the Eastern Pacific relatively cool, biologically productive, and full of marine life. Under those neutral conditions just described, the Pacific exists in a kind of balance. The western side stays warm and wet, generating heavy rainfall over places like Papua New Guinea and northern Australia. The eastern side stays cool and dry, keeping coastal South America relatively arid but ecologically rich. Everything functions within a predictable range. Farmers know what to expect, ecosystems are stable, and the global climate remains within its normal patterns. But then something shifts. The trade winds. Those steady, reliable winds that have been blowing from east to west for months begin to weaken. Sometimes they slow down gradually. Sometimes they reverse direction almost entirely. And when that happens, the massive pool of warm water that has been piling up in the Western Pacific has nothing holding it in place anymore. It begins sliding back toward the east, back toward South America, like water sloshing to the other end of that giant bathtub. This is the moment El Niño is born. As that warm water moves eastward, it physically suppresses the cold upwelling along the South American coast. The rich, cold water that normally rises from the deep ocean is blocked. Sea surface temperatures in the Central and Eastern Pacific spike dramatically. And because ocean temperature is one of the primary drivers of atmospheric behavior, the entire climate system above the Pacific begins to reorganize itself. Storm tracks shift, rainfall patterns move, jet streams, those fast-moving rivers of air high in the atmosphere that steer weather systems around the globe, get pushed into entirely new positions. The effects begin locally in the Pacific but radiate outward in every direction, touching virtually every corner of the planet. What makes this even more complex and more concerning when we're talking about a Godzilla-scale event is a feedback loop that climate scientists call the Bjerknes feedback. Here's how it works. When the trade winds weaken, warm water moves east, which causes sea surface temperatures to rise in the central Pacific, which then further weakens the trade winds, which allows even more warm water to pile up in the east, which raises temperatures even more. Each step in the process amplifies the next. The system feeds itself. It builds momentum. And once this feedback loop gets going with enough energy behind it, as appears to be happening right now in 2026, it can escalate very rapidly into something far beyond what a typical El Niño looks like. The cycle usually continues for several months before the warm water eventually exhausts itself and the system resets. But during those months, the consequences can be felt from the Amazon basin to the Arctic Circle. Now, one thing that makes the 2026 event particularly alarming isn't just the magnitude of the warming, it's the speed. Scientists tracking this event have noted that the transition from the previous cooling phase, known as La Niña, to the current extreme warming has happened unusually fast. In past cycles, ecosystems, agricultural systems, and weather patterns have had months to gradually adjust as conditions shifted. This time, that window appears to be significantly compressed. Farmers who depend on predictable rainfall to planting seasons have far less time to adapt. Marine ecosystems that depend on cold upwelling for nutrients are being disrupted before they can recover from the previous cycle. And weather forecasting models, which are built around historical patterns of how El Niño evolves, are being pushed into territory they have limited experience predicting accurately. The reach of El Niño goes far beyond the Pacific, and that's what makes it one of the most consequential climate phenomena on Earth. Different regions experience it in completely different ways, and sometimes the effects in one part of the world are almost the exact opposite of what's happening on the other side of the planet at the same time. Understanding these regional patterns is critical, because when scientists project what a super El Niño means for 2027 and 2028, they're essentially looking at these historical patterns and asking, what happens when you multiply them by several times their usual intensity? Let's start in South America, because that's the region closest to where El Niño originates. In countries like Peru, Ecuador, and parts of Colombia, a strong El Niño typically brings dramatically increased rainfall. The warm water sitting just off the coast supercharges the atmosphere above it, generating powerful thunderstorms and flooding on a scale that can be catastrophic for communities and infrastructure. During the 1997-98 El Niño, considered one of the strongest of the modern era, parts of Peru received rainfall that was 10 times above their normal annual average. Entire towns were washed away. Agricultural land was destroyed. The human cost was enormous. Now imagine those conditions amplified by an event that could be even stronger than 1997. On the other side of the Pacific, the story is almost perfectly inverted. Australia and Indonesia, which normally receive abundant rainfall due to the warm water pool sitting nearby, find themselves cut off as that warm water retreats eastward. Rainfall drops sharply. Droughts set in. And in extreme cases, the dry conditions become so severe that they trigger devastating wildfires. This is not a hypothetical scenario. It's exactly what unfolded in Queensland, Australia during the late 1990s, when that El Niño event drove what was officially recorded as the worst drought in that region's history at the time. Fire seasons became longer. Crop failures rippled through farming communities. Water reservoirs hit critically low levels. And all of it traced back to that one warming event in the Central Pacific. North America presents a more divided picture. In the southern United States, particularly along the Gulf Coast and across the southeast, El Niño typically brings wetter, cooler winters. Increased precipitation flows through the southern states, and storm activity picks up in ways that can cause flooding but also replenish reservoirs and ease drought conditions in some areas. Meanwhile, the northern United States and Canada tend to experience the opposite, warmer and drier winters with reduced snowpack in the mountains. Ski resorts suffer. Spring runoff decreases. Water supplies for the following summer come under pressure. Across Europe, the effects are more subtle but still measurable, with shifts in the positioning of the jet stream altering storm tracks and producing wetter or drier conditions depending on the season and the specific region. What ties all of these regional effects together is the fact that El Niño essentially functions as a global heat injector. It takes energy that has been stored in the ocean and releases it into the atmosphere on a massive scale. The 2023-2024 El Niño, which was significantly smaller than what we're now projecting for the coming years, was still a major contributing factor to what became the hottest year ever recorded on Earth. Multiple locations around the globe hit all-time temperature records. Coral reefs experienced catastrophic bleaching events. Wildfire seasons in multiple continents broke historical records. And that was from a comparatively moderate event. History has a way of showing us exactly what's at stake. And when we look back at the most powerful El Niño events on record, the picture that emerges is sobering. The 1997-98 El Niño is widely regarded as the benchmark for modern extreme events. It disrupted weather patterns across 6 continents, triggered floods and droughts simultaneously in different parts of the world, and contributed to one of the most widespread coral bleaching events ever documented. Scientists estimated that approximately 16% of all the world's coral reefs died during that period. Not from direct human activity, but from the thermal stress caused by elevated ocean temperatures. Coral bleaching of that scale doesn't just damage an ecosystem temporarily. It takes decades for coral reefs to recover, and some areas that were hit hardest in 1997 still haven't fully returned to their previous state. And yet, the event we're now tracking in 2026 may significantly exceed what 1997 produced. The 2015-16 El Niño was another major event that set records and disrupted climates worldwide. But there's a crucial difference between that event and the one that appears to be forming now. When 2015 happened, it came after a relatively calm period in terms of El Niño activity. The ocean had time to rest between major events. This time, we've barely recovered from the 2023. 24 cycle before the data is already pointing to something larger building in the Pacific. That rapid succession. One strong event followed almost immediately by an even stronger one. Is something that concerns atmospheric scientists deeply. It suggests that the baseline conditions in the Pacific may have shifted in ways that are making these events not just more intense, but more frequent. Many researchers now believe this acceleration is connected to the dramatic loss of Arctic sea ice observed over the past 2 decades. The Arctic is warming roughly 4 times faster than the global average, a phenomenon known as Arctic amplification. As the Arctic warms, it changes the temperature difference between the poles and the tropics, which is one of the key drivers that maintains the stability of the trade winds and other large-scale atmospheric circulation patterns. When that temperature gradient weakens, the atmospheric systems that normally regulate El Niño behavior become less stable and more prone to extremes. It's a chain reaction. Arctic warming feeds Pacific instability, which produces stronger El Niño events, which generate more global heat, which accelerates Arctic warming further. We may be watching one of Earth's major climate feedback loops tighten in real time. The most extreme historical example of what a Godzilla-scale event can do comes not from the modern era, but from the late 19th century. The El Niño of 1877 and 1878 is widely considered the most powerful ever recorded in the historical climate record. Its consequences were not just meteorological, they were civilizational. The droughts and agricultural failures it triggered across Asia, Africa, and Latin America contributed directly to a series of famines that collectively killed more than 50 million people. This catastrophic period is now referred to by historians as the Great Famine of 1876 or the Northern China Famine, and it remains one of the deadliest climate-related disasters in human history. A single El Niño event, one warming of the Pacific, produced a body count that rivals some of history's worst conflicts. That is the scale of disruption we are talking about when scientists use words like super and Godzilla. Now, the effects of what's coming in 2027 and 2028 won't be felt equally around the world. That's one of the most important and underappreciated aspects of El Niño. It doesn't just change the weather, it reshapes the economic landscape of entire nations. And because different regions experience opposite climate effects simultaneously, some countries may actually benefit from a strong El Niño while others face severe hardship. Understanding this unequal distribution of impact is essential if we want to make sense of the full picture. Let's look at what happened during the 2014-15 El Niño as a reference point. At that time, the United States and Mexico saw measurable economic benefits from the event. Agricultural output in certain regions actually increased, driven by favorable rainfall in areas that are normally prone to drought. Some economic analysis from that period showed a modest uptick in GDP for those countries, linked at least in part to improved farming conditions and lower energy costs from milder winters in the north. For farmers in parts of California, Texas, and the American Southwest, a wet El Niño winter can be a genuine relief after years of dry conditions. But for India and South Africa, the same event produced nearly the opposite result. Reduced monsoon rainfall in India, a well-documented consequence of strong El Niño conditions, put enormous pressure on agriculture across the subcontinent, where hundreds of millions of people depend on the monsoon for their food and water supply. In South Africa, drought conditions associated with that El Niño cycle cut into agricultural output, contributed to food price inflation, and dragged down GDP in a country that was already under significant economic stress. The same global weather phenomenon that was a mild positive for one set of countries became a serious economic crisis for another. Now scale that dynamic up to a Godzilla-level event. The disparities become much larger. Countries with diversified economies, advanced infrastructure, and strong agricultural technology will be better positioned to absorb shocks and adapt to changing conditions. Countries that are heavily dependent on rain-fed agriculture, that lack the infrastructure for irrigation or food storage, and that are already operating under tight economic margins will be far more vulnerable. Sub-Saharan Africa, South Asia, and parts of Southeast Asia are likely to face the harshest consequences. And within those regions, it's always the most economically marginalized communities: smallholder farmers, subsistence, fishermen, rural populations, who bear the greatest burden. The food production implications deserve particular attention, because food security is the thread that connects climate events to human suffering in the most direct way. El Niño doesn't just affect rainfall. It affects the entire agricultural calendar. Growing seasons shift. Pest and disease patterns change. Water availability for irrigation fluctuates. Crop yields in affected regions can fall dramatically in a single season. And because global food markets are deeply interconnected, a shortfall in one region can ripple through supply chains and drive up prices worldwide. We've already seen this dynamic play out multiple times, most dramatically in the 1877-78 event, but also in more recent cycles that drove temporary food price spikes across global markets. One factor that may help limit the worst outcomes, compared to historical events, is the significant improvement in our ability to predict these events in advance. We now have satellite monitoring of sea surface temperatures, sophisticated climate models, and international early warning systems that didn't exist in 1877 or even 1997. Governments and international organizations can, in theory, prepare. They can pre-position food aid, adjust agricultural planning, issue drought warnings, and coordinate emergency responses. The question is whether the political will and the institutional capacity exist to actually put that knowledge into action before the crisis arrives, rather than simply responding to it afterward. We've now covered the science, the history, the regional effects, and the economic consequences. But there's one more dimension to this story that deserves serious attention, and it's the one that connects everything we've discussed to the larger trajectory of our planet's climate. Because the 2026 Godzilla El Niño isn't happening in isolation. It's happening against the backdrop of a world that has already warmed significantly due to long-term greenhouse gas accumulation. And that background warming changes everything about how El Niño events develop and what they ultimately produce. Think of it this way. When a strong El Niño occurred in 1997, it was adding its heat on top of a global average temperature that was already elevated, but not nearly as elevated as it is today. Every El Niño event temporarily pushes global temperatures higher than the current baseline. In 2023, 24, that smaller event was enough to make it the hottest year in recorded history. Now we're looking at an event that could be significantly more powerful, pushing temperatures above a baseline that is already higher than it was just a few years ago. The cumulative effect of that combination, a stronger El Niño event on top of an already warmer planet, is what makes the 2027 and 2028 temperature projections so concerning to atmospheric scientists. It's also worth being clear about something that sometimes gets lost in the way these events are covered. El Niño increases the probability of certain outcomes, but it doesn't guarantee them. A strong El Niño doesn't mean Australia will definitely experience a severe drought, or that South America will certainly flood, or that the next 2 years will definitely be the hottest on record. What it means is that the likelihood of those outcomes rises considerably, in some cases to levels that demand serious preparation. Weather is always probabilistic, and even a Godzilla-scale El Niño can produce surprises. Some regions that are expected to dry out may receive normal or above normal rainfall. Some areas that are projected to flood may see relatively mild conditions. The global climate system is extraordinarily complex, and no single phenomenon controls it completely. What we can say with confidence is that the combination of factors now present, the rapid warming of the Central Pacific, the unusual speed of the transition from La Niña to El Niño, the broader background of climate change, and the potential connection to accelerating Arctic ice loss, places this event in a category that demands serious attention from governments, scientists, agricultural planners, and ordinary people alike. The time to understand what's coming is now, before the peak of the event arrives and its effects start showing up in weather stations, crop reports, and news headlines around the world. There's also a deeper question embedded in all of this, one that scientists are still working to answer with precision. Are we entering a new era where extreme El Niño events become the norm rather than the exception? The data from the past decade suggests that possibility is real. If the feedback loops connecting Arctic warming to Pacific instability to stronger El Niño cycles are indeed tightening, and the evidence increasingly points in that direction, then the Godzilla event of 2026 may not be a once-in-a-century anomaly. It may be a preview of the climate conditions that the next generation will grow up considering normal. That is not a reason for despair. It is a reason for awareness, preparation, and action. Understanding what El Niño is, how it works, and why this particular event matters is the first step toward being informed enough to respond intelligently. Whether that means adjusting agricultural plans, preparing emergency supplies, pushing for better early warning infrastructure, or simply paying closer attention to what our planet's climate systems are telling us. We will continue tracking this event as new data becomes available, and as the picture sharpens over the coming months, we'll be back with updates. If this video helped you understand something important about the world you live in, share it with someone who needs to hear it. Subscribe so you don't miss what comes next, and drop a comment below telling us which region you're in and how you're already seeing climate patterns shift around you. This conversation matters, and so does your voice in it.